Today we're looking at 6-8, zero product property, on using the zero product property to solve quadratic equations. All right. This is, again, 6-8 of your book. All right, when we're solving linear equations, our goal is to isolate the variable and to solve for x. So if I had a linear equation, I would add 10, and I'd get 5x equals 10, divide both sides by 5, and I end up with x equals 2. With a quadratic equation, we're going to use something that we're actually quite familiar with. We've been doing this since second grade, and so we're just going to use an old concept to help us solve some more difficult math. When I have an equation like this, x squared minus 5x equals 0, the first thing we need to do is to factor what can be factored. And we have this half of the equation can be factored. We can divide out a GCF. The GCF would be x, sorry. When I divide the x, I'm left with x times the quantity of x minus 5. Excuse me, I'm not dividing it out, I'm factoring it out. So I don't want you to get rid of it. All right, so now what I'm left with, I'm going to use something that we learned a long time ago. And the first thing is, if I have a number, 5, and I'm multiplying it by another number, and it equals 0, what must the number be in the box? Hopefully you said 0. And the same goes if I'm multiplying an unknown amount times a number 7, and I end up with a 0, what number must be placed in the box to make this a true statement? And we know that it's 0 because any number multiplied by 0 will give you 0 as a result. So knowing that 5 is just a factor, and I'm multiplying another factor, 0, to get a product 0. I'm doing the same thing up here with the quadratic. I'm multiplying one factor, x, my other factor, x minus 5, and all together it gives me the product 0. So it's a factor times a factor equals 0. So if I apply the same concept, we know that if factor times factor equals 0, then one of those two must equal 0. So what I do is I break down the equation and I set both equal to 0. X equals 0 and x minus 5 equals 0. I don't have much solving to do for this. X is alone. We know that x can equal 0. I can do x, add 5 to both sides, and I end up with x equals 5. So I have two possible solutions. We've got 0 and 5. Shouldn't put the parentheses. All right, so now I can check this. I'm going to check it in orange. Now let's go green. Let's check it. 0 squared minus 5 times 0. Remember, if x is equal to 0, then it should be equal to 0 in both positions. And that simplifies to 0 minus 0 equals 0. So that works. Now I'm going to try the other solution. Let's go lavender. All right, so if it's 5 squared minus 5 times 5, remember if x equals 5, all I'm doing is substituting it in. Is that a true statement? 25 minus 25 does in fact equal 0. So both solutions work, 0 and 5. And this quadratic has two answers, 0 and 5. Take a minute, copy the notes if you need to, and let's move on. Pause the recording if you need to take notes. So, the zero product property states if A times B equals 0, then A has to equal 0 or B has to equal 0. So one more time, reiterating, I take both factors and I set them equal to 0. All right, so one more time, I'm going to set both I'm going to set both factors equal to 0, x minus 4 equals 0, or x plus 7 equals 0. When I get them alone, I have x equals 4 or x equals negative 7. Now, since these are one-step equations, my expectation, you don't have to do the adding and, you don't have to do the inverse operations, because I know you can basically just take the additive inverse of negative 4 is positive 4. The additive inverse of positive 7 is negative 7. That would give you 0. So if you can mental math this and say what times plus 7, I'm fine with that. As soon as it's a two-step equation, I do want to see the inverse operations work. All right, now stop the recording and see if you can do number 2. Now check your work. Set x equal to 0 and x plus 3 equal to 0, and our answer should be 0 and negative 3. You can write it either way, in the braces or with the x equals. Make sure you get both answers. Now in the next one, it's not that much different. The only difference is I have 3 factors. So again, if 3 numbers multiplied together equal 0, that means we just have to set each of them equal to 0. Let me go back. Let me write it out for you. So where 3x will equal 0, I'm going to have x minus 1 equals 0, and x plus 4 equals 0. And then we know divide by 3, x equals 0, add 1. I don't really need to do this. I know in my head. And then I know that the last one's going to be x equals negative 4. So it's 0, 1, and negative 4. Usually I put these in order from least to greatest. I don't know why I didn't that time. Okay? So stop the recording. Actually, let's do this one right now together. So we're going to have x equal to 0. And remember, 2x minus 5 is equal to 0. Now this is one where you have to do the inverse operations because it's a two-step equation. I don't have to do anything for x equals 0, but for 2x minus 5 equals 0, I'm good. We have to do our inverse operations. So add 5 to both sides. We end up with 2x equals 5. Divide both sides by 2, and we end up with x equals 5/2, or x equals 0. Pause the recording if you need to take notes. All right, now pause the recording and do the next 4 on your own. Now check your work. Number 1, x equals negative 2 or x equals 7. Number 2, x equals 0 or x equals 7/3. Number 3, x equals 0, 1, negative 1, or negative 2. Number 3, x equals 3 or 1/4, negative 1/4. All right, Pause it if you need to take some notes, because I'm going to move on. All right, now here's where we really start to use it. Here's a typical quadratic equation. And now we're putting everything we've learned in Chapter 6 together. Number 1, I'm seeing a trinomial. So I have to factor that trinomial. I use my x marks the spot, what multiplies to negative 12 and adds to negative 4, and we end up with what numbers? I believe it's 6 and 2. To keep that negative, I'm going to need to make my 6 negative. Now remember, there's no coefficient here for that a term, so I'm just doing the straight x marks the spot, where what's the square root of x squared? It's x times x. And my plus 2 and minus 6 come in right there. I don't have to make them, I don't have to break down my middle term like I did when I had a coefficient over here. So I'm just, it's x minus 6 and x plus 2. So my solutions would be x equals negative 2 or x equals 6. Negative 2 and 6. Now remember, we're not using parentheses because this is not an ordered pair. You need me to write that. Oops. All right, so let's move on to the next one. What do you think we'd do first? Take a minute, look at it. All right, hopefully you are thinking about pulling out a GCF. So I'm going to factor out my GCF, which is a 5 and an x, and I'm left with x squared plus 4x plus 3 equals 0. So I keep my 5x. I have to break down and do my little x marks the spot, what multiplies to 3 and adds to 4. About 3 and 1. So I get x plus 3, x plus 1. My solutions, if I add all 3, is going to be 0, right? If I get negative 3 and negative 1. Stop the recording if you need to take notes. All right, so this is just more of the same. I'm going to divide out my GCF. I'm left with the difference of squares. X squared minus 100 is x plus 10 times the quantity of x minus 10. My solutions will be 0, negative 10, and positive 10. The next one, this is interesting. So remember, this is a perfect square trinomial. I know that because I have a perfect square, a perfect square. So the quick way to do that is x is the square root of x squared. The square root of 25 is 5. I know it's a negative and a plus, so I'm going to have a minus in there, and that's going to equal x minus 5 times x minus 5. I don't need to set them both equal to 0, because it's going to be the same thing. So why take the time? I'm doing it for the video, but you don't need to. My solution is going to be 5. It's going to be 5 here, and it's going to be 5 here. So in my solution set, I really only need to list that once. That's the only possibility that will make this a true statement. So if you end up with a perfect square trinomial. Now if you forgot how to do those, remember we can do x marks the spot. What multiplies to 25 and adds to negative 10. Negative 5, negative 5. Okay, so we can still do that. More of the same. Factor out our GCF. break down our difference of squares, end up with a equals 0, or -3, or 3. The next method, I'm going to have to do the coefficient where I have to multiply my lead coefficient. You know, it multiplies to -60 and adds to 11. Okay? -60 multiplies to -60 and adds to. So you got to start going through your factors of 60. And when you should end up with a 2x plus 5 equals 0, or 3x minus 2. Got to get the x alone. You should end up with 2 fractions. All right, now this is probably as complicated as it gets. In order to solve for n, the only thing you know at this point is how to use the zero product property. So the problem is my equation is not set equal to 0. So I have to set it equal to 0. I'm going to add 45n on both sides. And now I'm set equal to 0, so I can use my zero product property. Don't forget, every time you factor, you always have to start with your GCF. Divide all terms by 5n, factor it out, and break down that perfect square trinomial to n plus 3 times n plus 3 times 5n, and the answer will be n is equal to 0, or n is equal to -3. Okay, one more time, even if you have only 2 terms, I want you to pause the recording and try and do it on your own. All right, now check your work. Subtract 49x. I'm left with something that's looking kind of nice, but I don't have a perfect square with that x to the third, so factor out an x. Now I'm left with a difference of squares. Break it down to 2x plus 7 times 2x minus 7, and we end up with a 0. And don't forget your GCF of that additional x there. Okay, so we should end up with x equals 0, x equals positive 7 over 2, and x equals negative 7 over 2. That's basically the lesson for today. You can turn the recording off now. There's a couple more practice problems if you want to pause the recording and then check your work. Now check your work. Number 9, x equals 2 or 4. X equals -1/4, or x equals 3. And we are done. Stop the recording.